Recording in progress.
Okay. Oops. Now 35.8. So, okay, maybe I'll just quickly say it out. So let's say I have 37.6, I have 41.9, I have 35.8, I have 36.9, and then I have 35 degrees Celsius. Half an hour apart each. Do you think I have a fever?
I think the thermometer spoiled.
Yeah. What? But what makes you think that the thermometer is spoiled?
Fluctuation.
It fluctuates, right? It's never giving you a consistent measurement. How can temperatures change that quickly? Cannot. Person is probably God possessed, gonna die, if you believe that. But temperatures don't change like that, isn't it? So moral of the story here is, whenever we talk about information, factual, at least factual information or useful knowledge, we want to make sure of two things. First of all, did you cross-check with everyone to ensure that you are really measuring what you want to measure, and that everybody can agree that, yeah, this is what we are measuring. Okay? So whilst we still don't know the real truth out there, but at least we have a better chance at getting at the real truth, because now everybody has surveyed this thing and feel that, yeah, should be like that. Higher chance. Next, if we want to say something, this thing that is used and applied should always reflect the same outcome if you don't change the problem or whatever you're measuring. Right? Temperature should not be fluctuating like that. So once your information is now, sometimes they apply this way, sometimes they apply that way. For example, you tell people, based on your horoscope today, I think you're gonna have a dog of that now. Then the person comes in the evening and say, hey, today, Wednesday, I hit lottery. Then say, I think it's because let me see, I overlooked. Just now, the Mercury just went into your moon shape there, and of course you have a spot of good luck, but it will only last 5 minutes. Duh. You happily just changed. Right? And then suddenly the person tripped and fall. I think our Mercury left. You can't do this. When you say the person has good luck, you have to say the time period and the percentage. And then you can measure whether it really was like that. Maybe he's supposed to win $1 million, then but he has to pay $200,000 admin fee. But he predicted that you had only 80% good luck. Then you're accurate. Right? Get it? So what you say must follow through. Alright? Okay, now that we have done this, now the rest we can speed up a little bit. The rest. So the whole idea behind why things are called scientific is because you can maintain validity and reliability. How do you do that? You rely on a certain framework to do your investigation. So the picture here shows you, maybe I'll move my mouse over. The picture here shows you the framework. Alright? What people do is, they may start off individually with an observation. Alright? But what they will do is, they don't immediately just tell people their observation. What they will do is, they will maybe analyze a little bit. Meaning they try to distill out what am I seeing? Is there a general theme? And then they formulate some untested opinions about their observation. Next, they will test it. So from this part, hypothesis building to hypothesis testing, this is the part where you also have to read other people's work and see whether, so you Google search, you see whether people have already found out something about it. If so, no big deal. Just make use of it. If not, then let's say you have something new. You observe something totally, or at least somewhat original. So you read, as you build this part up, that's where you write the paper's introduction. Right? Then you devise a way to test out. Maybe you go to the field, you observe people, and you measure it. And once this thing is done, now look, why is this theory on top? Because that's it. One person can only accomplish all these steps. You can still publish, but you wait for another person to do the same thing. So usually what we do is we won't just directly, we won't just 100% replicate. What we will do is we will, so for example, I read, hey, this is interesting. For example, right, the way you do certain things, you act in a certain way, it will affect your decision. Now, consider this. This is a more specialized branch of knowledge in neuropsychology. I'll give you that as an example. Now, there's something called embodied cognition. So what's that? Like I literally say, the way you move your body might make you decide on, might influence your decision. So you are actually not your own boss. Something else is influencing you, but you don't even know about it. So the original paper could be like this. If you have someone, right, let's say you put a person in a seat and you have a person pull a lever. So every time they flash something random, and then every time they see certain thing, they just pull the lever. Plus random, or they push the lever. And it was discovered that when so all these things are random projections. So if you don't have the person move anything, right, they just so it's just 50-50. So let's make it simple. So let's say I flash this thing. So I ask you, hey, do you like this marker? To you it's just what the hell is just a marker? So let's say 50% like it, 50% don't like it. Normal, right? Because there's no meaning to you. But if you said that and you did this some of the time, so I have the lever for you, and you thought that you're doing another experiment, so you just pull the lever whenever you see a light flash. Another person push the lever instead. Okay? And you find at the end of the day, the group that actually pulled the lever, instead of saying 5 out, no, I think I like this pen 5 out of 10, which is like somewhere in the middle. They might say, I like this marker 7 out of 10. Whereas those people who push the lever, they may say, I only like this 3 out of 10. There is a difference. Strange. Why? But pushing and pulling, same distance. So the lever was like in the neutral position. If you pull it, let's say you pull it 30 cm towards you, those people in the pushing group will also push it. And the thing is measured so that what it adjusts to your strength. So if you are like bulky, right, then there is more resistance. If not, no, there's less resistance. So those people who pull and push, the total amount of force are the same. How come? You really think with your arm? Maybe Galvin was correct, right? No. What happened was, you are actually what? When you, okay, let's consider this way. When you like a person, will you push the person away or you pull it in? With heart, right? We are really doing all this because of our nervous system tells us to do this. But when you replicate what the nervous system tells the body to do, you can influence the brain to make a pre-decision. So next time you want somebody to fall in love with you, make sure you give the person, but you don't push all the way, you make the person grab the thing. Okay, I'm bad. Okay, never mind. Teaching you what? Brainwashing technique, right? Now, after reading this, so a person can feel that, so if we pull things closer to us because we like, what about warm and cold? Do you like warmer stuff or do you like colder stuff? Warmer. And the language itself already taught you, right? Ancient people may have felt this on them, so they tell you that warmer is like nice feeling, cold is not, it's like distant. So then, what people replicate, they feel that the concept to test is how you influence the nervous system in order to influence the person's behavior. So they are replicating this. But the replication is tweaked. So for example, in the second experiment by someone else, he might have someone come to the lab, some participant, and then he said, oh, I'm in a rush, can you help me please? Actually, that was the experiment. But the participant didn't know. The participant thought that, oh, I'm just helping, okay, what do you want me to help you with? So the so-called experimenter decided, can you just help me hold this glass of water while I go downstairs and pick up that file for you to fill in? So the person will be very happy, right? He said, okay, no problem, it's a simple task, I hope. But what the people didn't know is that all the participants were divided into 2 groups randomly. One group held a glass of warm water. The other drink a glass of cold water. And now, based on how the nervous system reacts to temperature, you find that they will also show a preference to like or disliking something that is random in their lives. Okay, it's no longer 50-50. So in other words, what I'm sharing with you is replication is that we still test out the main idea, but we might tweak it a little bit, so we test out something slightly different too. So no study is like an entire replicate, because that's just like copy and paste. At the same time, you can still test out the concept, but add on new information. So now the world knows that movement, all right, feedback to the nervous system, and the world also knows that temperature also can feedback to the nervous system, which will cause the person to be brainwashed. All right, got it? But this is illustrating that when people first observed, they wondered. Yeah, they wondered, are people really deciding things for themselves, or they are actually influenced by many, many things? So then they started to read and realize that, why ancient philosophers say about temperature? Why don't they come up with a totally new? Why do they just use the word warm, where it's really about temperature, and now you're talking about liking things? So they realize something. A lot of people come together, they talk about it, and they realize maybe we should test this out. And then just now the experiment I described to you, that was the hypothesis testing part, where they design something to check it out. This the temperature of water. Got it? Now, why do I give you such a lengthy thing? To show you that we don't take things for granted. It's not a joke when we talk about evidence-based. You literally have to devise something without telling the participants, so that they won't give you the subjective report and you measure them. So all the participants taking the glass of water, they actually didn't know. So when they had that form to fill in, they thought they were just filling in their personal particulars because they were registering for the experiment, plus a few extra questions. But actually the few extra questions was already the experiment measure their attitudes. Okay? Alright, so this is the thing. Then in other words, if you want to read, so here you can read about it. We start off with an observation. Usually it's just a wild, crazy idea. We formulate untested opinion, that's hypothesis. Untested opinions of what it is. We may read about it to better understand, and maybe what we observe is no longer new and original. Maybe someone else have found out about it. Alright, now here are 3 more things that we should avoid. Eventually, if you read about things, it's theory. If you have several people replicating them, and you found the same thing, so then you publish it as a collection saying that, look, we have found out something to explain behavior. And also you can predict behavior based on it. So that's theory. But law is only good if you are talking about legal matters. Some of you might remember, you learned about the 3 laws of thermodynamics in your secondary school. No, don't remember the 3 laws, but basically there's this term. There are something like laws of momentum, laws of thermodynamics, these kind of things, right? In natural sciences, things are more concrete. Alright? If you roll a ball down a particular kind of slope, you can measure the friction, etc., etc. The ball, unless you change the ball won't change by itself. Meaning, if you make it a rubber ball, it will forever be a rubber ball. It will not suddenly transform, alright, and then tell I'm an auto ball, and then try and become a rubber ball will always be rubber ball until it decays, right? Or decomposes. So in natural sciences, they are able to establish laws because things don't change. Do you think there's any human that you've met before that has not changed at all? Over, let me say, a period of 5 years? Personality never changed. Mood never changed. Yeah, I have fake people. Right? So humans will change. That's why we never have anything set in law. If you're looking at psychological theories, all the knowledge will never be called the law of this, the law of that. No such thing, because we humans will change, and even if you insist on not changing, you find that you still have to keep up with times. Alright? So, like 20, 30 years ago, we are not so reliant on cell phones. Today, you find that you just can't live without one. Right? So we change. And we avoid this means that we will also avoid simply relying on argument to force a point. This is called dogma. Now, all this will lead to what? No more progress. Moral of the story is these four things. The question is, why do people want to do this kind of rigorous way of testing? And after they test, they don't even set it in law, they call it a theory. Then after 10 years, newer studies come in, and then you just scrape the old thing and say that this is new human behavior. Because we recognize that humans are always changing. So nothing is set in law, not like natural sciences. So constantly you need a bunch of psychologists to find out the newer kind of behavior so that they can use it to explain and predict behavior, thereby avoiding the pitfalls of becoming dogmatic and stagnation in understanding human behavior. So this gives psychology some some strength, all right, to convince people. Now, earlier on, I gave you a description, right? But did you know that there are basically various ways of trying to find out about information? Meaning, I'm going to talk about two broad ways. Actually, it's not just psychology. I think in sociology, in a lot of the human sciences, human social sciences, sometimes in the natural sciences, we have something called qualitative and versus quantitative methods. Still no good. The lighting is really getting in the way. Yeah, I think the lighting is getting in the way. What I wrote, alright, for people online, is the word qualitative. Then the bottom word is quantitative. Now, what it means is that if you need to get people's responses, maybe you don't mind a bit of subjectivity, you use the qualitative method. So, for example, interviews is a form of investigation. So if you are not going to spend a lot of resources, you just want a bit of opinion so that you can start to plan how you're going to make a bigger study. You can always do an interview first. So you get some ideas before you begin the process. Right? But when you want to have numbers to predict what might happen if people do certain things, and you want to explain exactly how much change there is, you stick to quantitative methods. So in other words, objectively measurable methods fall into quantitative, the quantitative rubric. Those that require some form of subjectivity, responses, alright, then that will be qualitative. And what you see projected there, yes. So quantitative are objective, measurable methods that give you confidence to explain how much changes there is in behavior. How much changes? So two parts, right? Objective, measurable, leading to predictability because you now can talk about how much change. But if you want to only know what is the change, so for subjective measurements, sometimes they don't like the word measure, they just use the word observation. So subjective measurements, where it can let you know what is happening. So the focus is on what is happening. You fall back on qualitative studies. You really need both. Because what is happening is good for supporting explanations. Like you want to ask, hey, what is it happening? After that, you say, why is it happening? But after you explain, if it's just some kind of subjective explanation, it's no good. If your explanation is very sound, it should also be able to predict what might happen next. But you can't predict unless you have taken objective measurements. Alright? So you know ahead of time how much is the change based on the input. Okay? Now I'm going to talk about 6. There are many more ways, but these are the 6 most common type of investigations. So next time when you are exposed to psychological information, you know that okay, so there are all these things. Alright, and you also know why it's a science where people can have confidence. First of all, we can always there are certain studies that require you to just go to the field without manipulating anything. So no real experimental manipulation. You just sit there in the field and you observe what's happening. Like for example, maybe you're interested in children playing. Then you ask the question, I wonder how children actually play. So you have no idea, you just want to go on. So you just sit there, watch. Oh, hey, there's chasing around. Oh, there's also like on the playground they play pretend game. Oh, they are trying. So if those playgrounds they still have sand, right? So you might say, oh, they are also building what sand models. So these are called what? Naturalistic observation. It can be in the lab, very big lab, but so when you are just going to sit there, do nothing to the participants, and plainly observe them, focusing on certain behaviors, this type of investigation methods, they are called naturalistic observation. Okay? So no manipulation. This is good for what? This is good for knowing like what kind of things people do. That's why it's descriptive. So you can, after you've observed, right, you might even come out with themes. You feel that, oh, I think there are some things about children's play. Children will play, they tend to play in an abstract way. Like they have pretending. See, you are already describing that children don't just run around. You're saying that children run around because they are motivated by imagination. But people argue, oh, how much is the imagination? How many percent of the time? Oh, I don't know. Because you're just doing, sitting there and just see them. Yeah? This might be biased. What if the experimenter has a very bad childhood? Maybe someone who suffered from child abuse. And then when they observe, they may suddenly ignore some scenes, right? So the pros and cons of this is that it is very good giving you a lot of descriptive information. But you really don't know what is really making the children play. Because you have no control over their behaviors. So you can't really play around, not like ask the child, don't run, I just want to observe a little longer, you can't do that. So there's little control. It stops you from finding out the explanation, but you can certainly discover a lot of descriptive behaviors of what you are observing naturalistically speaking. And the last part is, the bad part is, there's a lot of personal biases. We call that observer bias, alright, and influence because you might be influenced by other people.
So is the minimum control a pro or con?
It's actually quite neutral, but from the psychological viewpoint, it's usually seen as that, the disadvantage. I will explain this later on when we look at experiments. Okay, so what you have is 1 pros, descriptive, 2 cons. Too much biasness, very little control over the situation. Okay? So if there's 1 pros, 2 cons, do you think this is a favored method? Yeah, not really. So that's why I say it's good if you're just starting out. You have no idea, you want to go and check it out a bit so that you can better allocate the resources for a bigger study. Then this is good. Okay, because this is free of charge. You just go there and observe. Right? Now, sometimes we don't just observe the big group, we actually track a single person or a single group. Maybe a single, for example, like one family. This is called case studies. Alright, maybe I should open it up. Yeah. So the pros and cons of case study is that it's very, very time consuming. Okay, let's look at pros first, then look at the cons, alright? Maybe I should have a bit structure here. Case study is good because it not only gives you descriptive data, but it gives you very detailed ones. Imagine you're not looking at every children playing, you're just following one child, like 24/7, the child play in the playground, the child play in classroom, the child goes home and play, you will be seeing all this. So you know the entire spectrum of behavior 24/7 in many settings. That's why the word deep is very emphasized. Okay? But when you are looking at things, you are still not discussing with other people, you are not taking measurements, so there is a tendency that you may misinterpret the behavior. Like sometimes you see a child play and then you go, wow, the child is so aggressive. But remember, you cannot compare the child's behavior to other children, right? What if all the children play rough and tumble games? Then you just observe this one, and you say, wow, this child is so aggressive because throw the toys. But if you go out there and see lots of boys will throw toys, that becomes a norm. No longer they're aggressive. Alright? So that's the misinterpretation part. When we have no other people to compare, we sometimes misinterpret the extent of their behavior. And of course, you are spending like 24/7, all your waking hours checking that one person. So another con is it's very time consuming. If you think of this, if you sit on the playground, you're observing, let's say 10 children playing. In 2 hours, you get data for 10 kids. And you call it a day. But now you have to what? You may be spending one whole day following one child. And if the requirement is that you need to write a report about 6 children. I'm consuming, right? So here we have what case studies are good also for exploratory purposes, just like naturalistic observation. Because the pros part is that it gives you a lot of detailed information, very descriptive ones. The cons, it's time consuming, it's also prone to biasness. Now at this point, I think I can highlight something. Notice that sometimes we hear things from the news. Do you think those are based on very controlled kind of observation, or is just the reporter goes out and just interview someone there? Which one? First scenario or second scenario? Second, where they just go out and interview people. Now, would that be considered as measurable evidence, or is more like naturalistic, or maybe just a case study?
Natural.
Yeah, because you just go to the field, pick up anyone, and ask, hey, what's the thing? Wow, are you frightened by the situation, right? So it is not a good reflection of the general population's behavior. Sometimes people think, oh, when they observe a disaster, everybody should panic. So they go to the field and interview one person, then one person, interview me. Oh, really panic. And then they conclude and they put it out on the news report. There was a lot of panic when the buildings collapsed. But what they didn't see is there were also hundreds of volunteers there helping people. Where's the panic? Right? So news may not be accurate because they usually rely on this kind of things. So that's why we don't really quote newspapers. You can cite if you want to describe the event. But be careful if you want to distill out some kind of explanation, be very careful. Okay? So one way out is that sometimes all these reporters, journalists, they do a survey. This is also acceptable. So what do? They go out there and ask you, can I have 5 minutes of your time? Anybody never get pushed when you want to take public transport? You go to MRT, you go to the bus stop. Can I have 5 minutes of your time? When you fill out a form that says, do you like coffee, tea, or me? You circle 1. You 1 to 5. Alright, how much do you like me? 1, 5. This kind of things, they are surveys. So surveys are usually filled with very simple questions. And some of them have numerical options. Then you just pick one. Right? So what's the good about this? Because your questions are already stated. So, and then you will get some kind of various opinions from it. So again, it's the description is there. At least you will know whether people like this or they prefer that, something like that. And there's one thing is, this is not time consuming. Why? Because one surveyor can reach out to hundreds of people in a day, depending on how lengthy your thing is. I mean, if you have a 2-hour survey, of course, then it's not. But if you are just 5 minutes of people's time, you can definitely reach a few thousand people in a day. Right? So we have very large numbers. That's good. We like data, lots of it. Okay? But because you are not manipulating anything, you are just going there. Maybe the person at the time of feeling down, they will just have their feelings there. Then another person who is like, wow, feeling excited. So there is no control. You will eventually still face biases. So then people ask, so what's the use of survey? This portion here, large numbers. Alright? Oh yeah, maybe I should do this. Okay? Large numbers. This part, right, when it gives simple numbers, simple responses in very huge quantity, you can quickly condense it and then what? And do prediction. Yeah, you will know the trend. So you, with a lot of people responding, right, you can easily say, so do you support? You cannot use support. Oh, yeah, I'll deal with this little bit. Now, so for example, if you are surveying, like, how shocked were you when the thing collapsed? Now, 1 to 10. Okay, now let's try this. This is 9. Jeremy, were you shocked by this? But when we don't know, so 1 to 10. 1, no big deal. 10, the shockest ever in your life. 6. 6. Let's go down then. Sorry, you are Judy.
5.
5. Louis? 4. Okay.
3.
You are 5, 6, 5, 4, 3, 2.
Oh, it's slow mo.
3.
7.
Now you sum it up, right? We now have 6 numbers. If you divide it, you're gonna get about 4.5. Now if 5 is in the middle, so do you think people are very, very shocked? But now you know the trend, right? Now you know that when classroom items collapse with a loud bang, people are only 40-45% shocked. See, you can tell the trend. So you want something shocking, right? You gotta have maybe say a new person running to an Orchard Road. Then shocking. So then that makes good advertisement. Big things falling with a bang, no good advertisement. That's the idea behind survey. It tells you the trend. It also tells you roughly what can you do. Right? So that's why during voting period, people love to conduct surveys. We know the trend. Who will be the next government?
But another pro for the survey, you also can structure your questions,
Yes.
focus points.
But all these are filled with, just now you learned, right, there's a lot of biasness. So one thing that psychologists like is that they prefer something called experiment. Now, instead of, if you think back just now, actually I already mentioned experiment. Remember the glass of warm water versus glass of cold water? So you set up a situation where you manipulate maybe just say one item. Now in that experiment I shared with you just now, the cold water, warm water, what was manipulated? The temperature of the water. The rest were all the same. It was always the same experimental. It was always the same story she told the participant. Oh, I'm sorry, I forgot to bring up your form. And everything, the setting, the aircon temperature, everything was the same. except maybe the reporting time. That you cannot force people to always come at 2 p.m. Okay? So there is a little bit of error, but do you think it's a major error? Like, no, some participants come at 2, some participants come at 3 p.m., some participants come at 4 p.m. Is it a big error? Probably not. Alright? Yeah, I mean, if we have morning and afternoon groups, then maybe, but if we just look at, maybe if you're concerned, you just make sure that the experiment is only conducted in the afternoon. 2 p.m., one person comes, 3 p.m., another, 4 p.m., 5 p.m., and stop the next day. So only very little possible error, and you manipulate that one thing. What's the glass of water? Right? The temperature. So experiments have very good control, which means you can tease out biasness. Because if you use the same glass all the time, it's just the temperature of the water, you know that the people's behavior will not be affected by the glass pattern because they are all seeing the same thing. Alright? And if you have large group, let's say you have 30 or 40 people doing the same thing. Now some people may be introverts, some people may be extroverts, right? But if I have, let's say 60 people, then there will be a good sizable number that is like leaders, a sizable number who is introvert, a sizable number who is extrovert. Then the personality no longer affects the study because we have a very good bunch of mixed people. We are really only looking at the temperature of water affecting their nervous system and how it translates to a certain attitude. So experiments are like that. They are good. Why? Because we remove biasness of what? We don't assign people. First person comes, you go to cold group. Next person comes, warm group. Then cold group, warm group. I don't care whether you're fat or thin, tall or short, or whether you wear specs or don't wear specs. It's always random. In the end, the group of cold water would be a mix. So it would be the warm water, right? So we take out selection biasness. It's no longer due to your own input. And when we tell people, oh no, you are supposed to be here to rate how consumers behave according to certain stories. But actually that is the fake part. So people all never thought of it's the water. You are taking out their what? Chinese has a very specific term for this. It's called 心理作用. In English, it's called placebo. Meaning, I do not know other languages, alright? But otherwise, it's basically if you are made to think in a certain way, you might just self-fulfilling prophecy and do it that way. But you see, notice nobody was told we were looking at a glass of water. I just wanted you to fill up some information about consumer behavior. But when they were holding, they were already in the experiment. So because people were not primed, they don't have a preset mind for this. I will let you watch a video of how powerful placebo effects are later on. And of course, since you, the experimenter, right, you decided that I will not assign people, I know, randomly they come, this group, that group, this group. Not only are you free of selection bias, then you behave all the time the same. So the experimenter actually rehearsed saying the line, exactly the timing, and then giving the glass with the right hand, and that's it. So in this case, I cannot even put in my own biasness. Right? But maybe I see a tall guy, I feel that I so no self-confidence. Please. But then I see a short guy, it's not such thing. You act through all the way. So no more experimental biasness. Okay? So that's why we like this. And in case you read something technical, you'll find that there are these words. Sometimes they tell you this thing called independent variable versus dependent variable. What are these two words? Independent variables refer to all the conditions that we manipulate in an experiment. Like in this case, you identified the temperature of the water. So that was the only thing manipulated in that experiment. In the lever thing, it was just a matter of pull or push lever. So if people say, hey, you know what's the IV? Not your intravenous drip. What's your IV for the experiment? Oh, it was the temperature of water. Okay. Sometimes when you have to review all those scientific texts, right, they will they will say the all the detailed things first. After that, they keep writing this word independent variable, then you what's that? They are referring, so you only see it once. They're referring to where they wrote it on the top. What are the things that they have manipulated? And then those things, those conditions that we measure, because when you manipulate something, obviously something else will change, right? For example, when exposed to cold and warm water, the person's liking and dislike will change, correct? So if you survey that liking or dislike, that part that you measure, so what the condition that you measure, which will change as a result of the manipulation, is actually called the dependent variable. So again, all the scientific texts, they may say a few times all the details. Then after that, they just say the dependent measure is blah, 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 blah. So they start to report numbers. And people get confused. What is this dependent measure? What is this dependent variable? So now you don't have to become confused. When you read, you know it makes sense. Somewhere at the top, they will talk about what they are, the method section, right? They will tell you what they're going to manipulate. After that, they will not repeat what exactly it is. They may just throw in these two technical terms. But you read the context, you will know. Okay?
Mr. Lam,
Yeah.
question for this one, right?
Mm-hmm.
The control group, is there like a specific minimum number of people needs to do what?
Yes. It is. Come to that. So now we move to what is experimental group and control group, right? So the experimental group is usually the group that will undergo this thing. Meaning there are certain things manipulated. In other words, there can be a third group in the experiment. One group help warm water, so they feel the warmth through the cup. Another group was holding cold water, alright? So ice chilled water. Now, there is actually a third group. A third group held the cup without any water. So they said, can you help me hold this cup first? The experimenter said that, but that cup was without water. Okay, while I go down, so you help me hold, and to make it look real, right? The person was like, wow, carrying a lot of things. So I said, can you help me hold this particular measurement device, which is actually nothing else. It was just an electronic counter to appear like, it was very cluttered. And then the glass. So that glass, there was a so-called control group. What's a control group? Control group means the group that has no manipulation done. You're holding an empty cup at room temperature. No manipulation. The manipulation was actually a 54 degrees glass of warm water versus a 16 degrees glass of cold water. That was it. That was the experimental group. The control group just held a glass, saw that they still have something, but there was actually no manipulation. Just normal room temperature. So in an experiment, there must always be a few things. Conditions you manipulate, the ID. Conditions that you need to measure because they will change as a result of manipulation, DDs. And you need to make sure that to tease out all the biases, you want to also control for placebo. Make sure you don't tell people certain things. Like, I really want to know how temperature affects you. And then you need a comparison group. So that after manipulation, right, you can compare them to a group that has not been manipulated at all. The glass, the empty cup group. Okay? Question? When you have all these conditions in, you know that the data, the measurement you get, it's going to reflect very strongly what actually happened to the person when they behave. So with that, you can safely explain why certain behaviors have occurred, why they changed. Now back to Stephanie's question, is there a minimum number? Well, it depends on what you are looking at. The more conditions you manipulate, usually the bigger the control group. As a rule of thumb, if we are not too sure, we usually will take 30 participants as a cutoff. No, not cut off their legs.
Oh.
Anyone from 20 to 30 participants is a good number to be the control group. So 20 to 30 is the cutoff mark. If you go below, that's not so good. Textbooks will usually quote you 30. But in real life, we may be okay with 20. But there is no fixed rule. Why? Because it really depends on what you are looking at. For example, in certain very physiology, biological based kind of experiments, we have control groups that are like only filled with what? 6 people. But why 6? Because there's only so much the body can change. So we have a very tiny group, but it's good enough to standard there already. But if just now that glass of water, no, I actually have one. I have 30 people. So total 90 people, 30 in each tested group. The empty glass, the warm water, and the cold water. Okay? So there is a certain thing to control the sizing of the control group or the every group. Usually you will see the number between 20 to 30 as a standard. Alright? Textbooks will usually put that 30, but don't take it that it's cast in stone. No, it's not like that. It depends still on the experimental situation. Then we say then how people fix it? Because when we read from various people's work, right, we realize that there is a certain number. Then we run a statistical test to check whether this number is good enough. Then we decide on how much is the number. In real life, that is how technical it is. Okay? Now, I'll tell you what, I'm going to show you a video, but I think we should all go for a break first. Because there's already a lot of information, right? After today, then it's less dry. Let's go at least more applicable stuff. So we go for a break, come back, you will watch a video showing you why there's a need to maintain a lot of control during experiments, why it is good, and how powerful placebo's effect are. Okay, I see you it's about 8:25 now, I think. Yeah. I see you at 8:45? Okay. Okay.
Energy pouring out.
I can feel where the energy is balanced and where it's not balanced. I can feel where it's intense. I can feel it's depleted.
Then she says she channels the healing energy of the universe through her hands to you. There's no scientific proof that this works, but the patient says that doesn't matter.
I don't need explanations because I have faith in the process. That's a really wonderful thing when you feel helpless, terrified, when you're given a diagnosis, like I was.
It's hard to argue with satisfied patients. But 2 years ago, a 9-year-old girl in Colorado thought that for her 4th grade science project, she'd put therapeutic touch to the test.
Today I'm going to test you on how well you can feel the human energy field.
Emily Rose's test was simple. She asked practitioners of therapeutic touch to feel the energy from her hand. But first, she had them put their hand through a towel and piece of cardboard so they couldn't see where her hand was. She didn't ask them to heal anything. She just asked the most basic question.
Tell me which of your hands you think my hand is over.
Left.
Again and again, touch therapists failed the test.
Left.
Amazingly, they kept volunteering to take the test. And even when they failed to do better at picking the correct hand than they would have done flipping a coin,
Right.
their faith in their skills was not dimmed.
Okay.
This woman guessed right only 3 times out of 10.
How do you think the test went?
I think it went very well.
Okay, you got 1 right. Sorry.
So, were they embarrassed?
No, not really. Some thought if you got 4 out of 10, right, they thought you'd pass. And obviously they didn't know their statistics.
We asked more than a dozen therapeutic touch specialists to come here and take your test, and not one would. Does that surprise you?
No.
Why is it?
Lots of people think that I'm scared I'm really good.
Well, not that good. Though Emily's test got publicity, it was published in the prestigious Journal of the American Medical Association. Since then, therapeutic touch is practiced more than ever.
80,000
Oh, we can't hear you.
Mr. Lau must unmute yourself.
Okay, online people, sorry, I was rattling on and I was saying that, but this is the summary. I was saying that when those therapeutic touch people claim that it worked, they probably tested it. They had people open their eyes and then, can you feel my energy? They will literally ask. This is very similar to what we mentioned just now, like qualitative studies. There is no control. There is no taking out of placebo. There is only, and all the participants may come in with, I feel good kind of thing. So this will affect the way they make judgments. So of course, when they feel good, you're going to get very high responses. But once you take out all this placebo, you put people to, you control the situation so that there is no subjectivity. And this is what happens, right? Even when it's 4 out of 10, but the thing is, would that really diminish people's interest in something when they strongly believe it? So belief is belief. Facts are facts. This has been enacted throughout history. Humans can be very fanatic about their beliefs to the point where they kill another person over it. And it's not for a good reason. Not for a good reason meaning because they did it for either false claim, falsehood, or some useless, non-productive things. Now, one of the most common things that everybody can share, can appreciate as how strong this is actually, and this I want to tie into something else. So let me finish up with the story first. The simple question to ask is, do you think the world is round or flat? Nowadays we think that it's round, right? But the first proof only came about 500 years ago. Right? Now prior to that, what do people believe? The world is flat. But the question is, what do you think people, the flat world believers, what do you think they do to people who say that no, the world is not flat? They can kill them, right? They can burn them, they can kill them, they or they ostracize them. Now, you can have the strongest belief, but that will not mean that it is valid. We still have to test something out to make sure that they are valid. We test them out several times to make sure that they are reliable. Okay? So that is what builds the current knowledge and technology that we humans have. Okay? The same thing applies to psychology. So if you have confidence that, okay, so our quality of living has improved, okay, certain things are better explained nowadays, this kind of principle is also applied to psychology. That's why I said earlier on, why if you still stick to philosophy, if you only speculate without showing evidence, then people shouldn't have so much confidence. On the other hand, when people say they have confidence in certain information, certain outcomes, that's because there is good evidence to support it. But one thing I'd like you to keep in mind is good evidence doesn't mean that it will not be obsolete. Today, do we have the most perfect tool to measure anything? So tomorrow, when we invent newer tools, you find that the so-called theories will be sharpened. That's why there is no law, there is no dogma. It's not just, earlier on I mentioned that humans change. At the same time, technology will allow us to more precisely measure the changes. So even if we remain unchanged, you still can't have a law for human behavior because there will be better measurement devices. So this marks the difference between natural sciences and social sciences. So in all social sciences, there's no such thing as a law. Alright? Now let's finish up with the video. The video shows you how powerful. You already see some impact of placebo. When people totally believe, right, they won't sway. But with that effect, now they didn't change their minds, one thing. But would that even affect their physiological responses? Now that's powerful. Why? Because physiological responses are supposed to follow what the amount of hormones and whatever you have. Okay, so let's take a look. Alright. Can bodily processes be overcome because of or changed because of just mere placebo effects? So it's like if this person feels that he is recovering, is it really because of therapeutic touch? Or is it really because you have to believe? Now the key here is, okay, maybe I talk about the key later. Let you watch first.
Do anything physically to anyone. It's just that if you believe in them, they sometimes can have an effect. The placebo effect is called. If you think the therapy will work, that alone may make you feel better.
Group 1 will be getting a substance that is a stimulant.
At our request, psychiatrist Michael Aronoff told these students and teachers at Manhattan's Kaplan Educational Services that for a test, he would give some of them a stimulant and others a sleeping pill.
What we are interested in is the effect on your usual sleep pattern.
And if we like it, can we get it anywhere?
What they didn't know was that they were all given a placebo, an inert pill that doesn't do anything. The result? Well, 2 students felt nothing.
I had no effect from this at all. It didn't change my sleep patterns. I thought it was a psychology experiment.
But 3/4 of the group felt a difference, some a big difference.
I felt great in the morning, even though I had much less sleep than I normally did.
I would love to take this drug every day of my life if I could. So, if you know the name of it or where I can buy it, it would be beneficial.
It was wonderful. I got good sleep, sound sleep, didn't wake up. The phone could have been ringing off the hook. I wouldn't have heard it. It was that deep of sleep.
Some reported side effects.
30 minutes after I took the pill, I got a little dizzy.
Then they learned the truth.
You all received the same substance. You all received a sugar pill.
I'm not looking forward to being on national TV and saying that I took a sugar pill, and boy, it made me tired.
I did feel tingling in my head.
Okay, so unfortunately she is on national TV, and that is the power of placebo effect. There are many experiments looking at when you plant a belief in someone, how might that affect the person, including removal of pain. So we have, although there are hypnotherapy users of, for example, right, delivering babies. Now so that mimics the placebo effect. So when a suggestion is put into the person's mind, unfortunately, it didn't work all the time because people can still resist. Okay, but let's look at on those situations when it worked. So about 60-70% of the time when a suggestion of painlessness was planted into the person's mind, so that mimic a strong belief that it's not painful at all delivering a baby without anesthesia. And literally, the mother actually felt no pain at all. She was happily talking away, no anesthesia, talking, looking at the procedure, delivering without any pain. Alright? Yes. So that's why, because it has a 60-70% chance of success, people in US, they actually can opt for hypnotherapy to be applied for a painless delivery. Yeah, it's just not happening here. Not yet. Okay? And that's all. There are various experiments, some on pulling out molar tooth, where they were given saline injection, but these patients think that they actually received anesthesia. So they painlessly had their tooth extracted. Okay? Even though it was just saline. Saline means salt solution. So that's how powerful placebos are. If you don't control for it, it's going to mess up the responses you get. When there is really no effect, people will tell you there is an effect. And they literally behave in that way. So that gives you more meaning to this phrase called mind over matter, alright? But what is the implication? Think about it. Do you think if you don't have the ability, let's look at the pain. If you really have no ability to overcome the pain, would it really have worked? No. That means if we totally believe that we can fly, because we have no wings and we cannot fight against gravity, but you really believe you can fly, can you really jump out the window and still not smack? No. Yeah, no. So meaning, placebo effects really is simply unlocking something that is in you. But there must be a strong belief if you, either you can do it because you naturally have that ability, or you have that ability hidden, but because you believe that it is real, it becomes real. Okay? So for example, there was even experiments showing how people could learn Shaolin Kung Fu very quickly by hypnotism. Now, we all know that from documentaries, don't talk about those fictional shows. Let's look at documentaries. Documentaries have shown that those Shaolin martial monks, they practice for like 10 years before they get all these super prowess. Like they can throw a needle and it will smash through glass. So what happened was the lay person was surprised. Now that wasn't a very good one because it was really a case study. So the size was minimal. But it was shown that after hypnotism, the participant, right, could actually cut wood with paper. So they just take a paper, they just swing it as fast as the monk, and they just chop through. I think the wood was like this. Now, how could they do that? Because when the suggestion was planted in, and they truly believe it unlocked an ability to have very precise control of muscle and speed, right, from the arm. So normal circumstances, we have to practice a lot. So you can actually achieve certain outcomes either through lots and lots of practice until you can master it, or you can have it planted in. Other side effects, yes, because the person who did that after that was very, very tired and felt soreness all the way. But of course, the muscles were never meant to do that. At least there was no way for the muscle to release all the build-up energy that in turn became lactic acid afterwards. Alright? So, but a long-term practitioner would have already gotten accustomed, so no problem. So that's the thing. First off, can placebos work? Yes. Is placebos without side effects? Maybe not. But if we want to know the truth, we have to control for it, right? Next thing is, placebos work because we already have the potential for it. Which means, if you rewind back just now, right, would these people who went through the touch, if they found another free of charge way to believe that in fact, do they still need to pay hundreds of dollars for the services? So this is another issue, but this is beyond. The discussion of placebo, we won't go beyond this. One thing I like you to keep in mind is, they all work because of a human feature called belief, strong belief. But if we have the potential to do this, why should we pay hundreds of dollars? We could always train ourselves, maybe even do self-hypnosis, and then we can still have that effect while saving resources. In this case, costs, right? So there is a lot of, this is not the place for us to talk about placebos. There are other places. All I want to show you is the power of placebo and why they need to control, and a little bit of implications about the use of placebo. So if you go to places like Germany, almost 50% of the doctors will prescribe placebos because it will work, and because it's sure you can surely avoid the bad side effects from a real drug. You can't do it in Singapore because there is legislation against prescribing placebos. So this is also cultural. Like in Germany, they may be very advanced, but they also strongly believe in natural approaches to health. That's why they can accept placebos. But in Singapore, we are very much more afraid of what? Facts. So we will not allow the use of placebos because then anybody can just simply plant the leaves. Because this is our culture, right? We started sometime in the 60s, 70s, we started to progress. But at that time, you realize that Singapore was a mess, a lot of things were unstructured. So we built a system that prevents the practice of quackery. Okay? So these are things that will always be part and parcel of humanity. Alright, let's finish up. Just now we talked about this thing called, let me go back, survey, remember? Alright, so let me switch to the screen. How strange, it's not screen 2. Okay. Remember just now we talked about surveys? Yeah, this one. So the thing is, when surveys come back, what do they usually give us? So they, scroll down. Surveys are good at giving us trend, remember? But you can't just happily predict the trend. You got to know what is so-called the input. So this is the last thing about research methods in psychology. I want to highlight something that is constantly used in the world and in psychology to predict trends, but at the same time, I want to show you that there is flaw to this. Alright? Now let's consider this scenario. If you are asked the question, right, do you think a broken family makes a child more likely to become a delinquent? Yes. So in other words, right, some people would then conceptualize and think that broken family is the cause of delinquency. But then how do you think? Then how do you then reconcile this point? Broken family leads to broken family, right? There's increase in broken family. So let's say, right, we have more years of living in a family of divorce, and there's also more quarrels. So when these measurements of this go up, you also see the child becoming more delinquent, so flouting more rules. Now, the lay people out there, you show them this trend. My question just now was, would they then think that, yeah, I think broken family is no good because it will cause delinquency. Now, why is it that some of you say no? It doesn't cause.
Because not every child will be delinquent.
So then what causes delinquent behavior? It's correct, alright? So let's say we have broken family. Okay? We are saying that it leads to delinquency behavior. Okay? But actually, it is not direct. There are actually other things. So meaning that you're saying that it doesn't cause this. So technically what they will tell you is delinquency is not explained by broken family. What is happening is there is something else here that's like that. So what is this?
The causes.
The causes. Think about it, yeah, the causes. So what is, okay, now I show it to you all. Can you name at least one of the causes of delinquent behavior in children?
Lack of security.
Lack of security. So there is lack of security in a child. What about lack of warmth? Warmth in a family. Okay. So we have no warmth.
No guidance.
No guidance. Okay, I think that should be enough examples. So either you have no guidance, it will lead to likely cause delinquent behavior, correct? So these are the causes. But what is happening is some of these things will appear within a broken family. So when you do a survey, you have no idea whether you're surveying this or that. The surveys are usually not clear. And when you try to be clear, maybe you ask people, do you think you are not showing enough warmth to your children? Now, this is a very bad statement for a parent. Most parents don't like to feel that way. So even though they are no single parent, they might say, no, I work very hard to make sure my child is okay, so I have given more. Right? So if you ask people like that, it becomes introspection. It's no good. They will give you probably incorrect answers. Or at least not so objective ones. So your surveys you can never ask directly. Unless you do an experiment, you bring them, maybe you then video cam them, you observe, you're not going to get the answer. So in surveys, we are unable to ask very objective questions. Maybe at the most, you just get the person's preferences and that's it. And that means what? In certain conditions, the real causes will appear, but you can never directly ask about the real causes. So in other words, surveys are only good when you measure two conditions, either here or here, but a lot of this cannot be found out. So this part will give you inaccurate things. The only accurate thing will be when you when you do a survey, and a survey you need not always ask. You could be going to you can still ask the child at least one part. Maybe you ask the child, so how long have you been living with your mother and father separated? So the child might give you a number of years. Then you go to the school record. So usually all the children will have a file. So the school record may document when they cause something like an incident report. So then you check. So your surveys on the incidents need not be asked. You can still, of course, ask them. And then after that, you tie these two together. You look at the way they change. Whether the numbers here go up, will it cause the numbers here to go up or go down? Now, in a nutshell, whenever we investigate two or more conditions, and we look at how their frequency or their numbers change accordingly, this is called correlational studies. This can be done through survey methods, and this kind of method is best to illustrate trends. Like once you notice that there is increasing numbers of broken families, so the trend is then we got to take measures to counter the rise of delinquent behavior. But if a person comes and asks you, hey, how come it's happening? You can't really say, oh, because no, it's just that the family is broken. You have to explain it. Sometimes when children are in broken family, they are lacking in warmth, they don't have guidance, blah blah blah. So you start to explain this way. In other words, don't mix experimental methods with correlational studies. Correlational studies deal with this too. Usually looking at the changes and giving you the trends. Experimental methods, they deal with this, all this reasoning behind what's happening. Which brings us back to one thing. Do you think smoking causes lung cancer?
Correlates.
So we've always been told that smoking causes lung cancer, right?
Correlates.
It's actually a very powerful correlational study. But there's one thing about correlation. If your correlationship is in the numbers of tens of thousands, then probably it highlights there is some kind of a cause. Ultimately, they did discover that the causes is not because of smoking, because of the chemicals, and they have identified that out of the 4,000, about 100 over are the deadly ones. Right? So, of course, do the people out there care about so much? Not really. Some of them just want to know the trend. Like somebody already got coughing out blood but not cancer yet. So you just say, oh yeah, let me share with you, this thing will increase. They don't need to know the cause, but they know the trend and they are willing to change. So this illustrates the usefulness of surveys. Sometimes people are not interested in listening to explanation. You can just show them a trend, and it's good enough to convince them that they need to do something more adaptive. And that's good enough. Alright? But what happens when if you read your so-called journal reports and what, you find that you will come across some of these. By the way, I will skip one slide, I'll show you something first. This is what I want to share just now. See, I've been emphasizing when you discover a trend, it means there's a correlation between two conditions. It doesn't explain anything just yet. Remember I said that. So if we crystallize that warning, it becomes correlation. Correlationship is not causation. Never explain what is happening by looking at trends. You see the trend, you can report the trend and say that I think there must be some other conditions happening too. So you make a very conservative statement. This is useful so you will not mislead people. Okay? Now, let's move back. Technically, whenever we plot out correlation, so if I were to use, let's say the x-axis, I plot broken family. Alright? If you look at this thing here, this is the x-axis, right? So this is the x-axis. Alright? Now if I were to change broken family and smack it here like year 1, year 2, year 3, year 4, and I put the number of incidents, delinquent incidents, you will actually get a graph very similar to this. Because why? This graph, right? Whenever you plot two conditions on the xy axis, if they are not related or there is no trend between them, you will not see something like almost a line. Instead, right, the dots will be all over the place. If you join all the outer dots, right, it forms either a big circle or a big square, something like that. But every time this big circle or square start to compress and become like a thick line, the narrower the so-called thick line, the stronger the trend. Or the stronger the correlation. So even without numbers, right, when people just because let's say some people they learn the statistics, some people they didn't. So what happened is that when they didn't, but they still want to know whether there's a trend, they just plot it out like that. And once they see that AAT is not like randomly widespread, they know there's a trend. Okay? Who would do this? Policymakers. Not all policymakers study statistics or want to know human behavior exactly. So what they do is they want to, hey, tell me what is this? So they show the thing, this is like that. So the policymaker, I think it is room for worry. We better plan to put budget and to prevent the problem. So that's what's happened. So human behavior works this way too.
So when we say correlation is not causation, so it's safe to say any form of correlation studies or examples are not factual.
You should say they don't have explanatory power. But they are factual because they are there. The trend is already existing. Okay? So when the trend exists, it means some part is real. So there is a significant level of facts.
Or not conclusive.
But you can't really explain. So that's why I mentioned earlier on the conservative statement. We can tell people, I think this thing exists. There is a concern now that, like for example, divorce rates climb. So when there's been climbing, then we realize that there's going to be more social issues. So we know it's there. We just say that what are some of the reasons? Now sometimes you can't even just look for psychologists. That's why some of the policymakers actually went to speak to sociologists. And then they try to devise ways to prevent this from happening. I think they can't stop divorce rates. As people become more and more educated, more and more affluent, they chase after extra values in their lives, like freedom. Alright? Freedom from commitment. So divorce rates will climb as our society economically and technologically progresses. But then people can be taught about how to stay committed. People can report about what? Selection of their partners so that they are likelier to not happily just say divorce. So we know that the explanation behind this becomes what? Becomes something like, oh, it's because of a chase after other values, differing values. This becomes the explanation. But you can't really study that, you can only measure whether divorce rates are increasing over the years, right? Okay, so I hope that illustration can answer not only the question but also help you better understand. Now, so here is what I mentioned just now. Is there really a trend between two conditions? If you look at that, you will know. So next time, right, if you plot anything out or you see somewhere where they present a graph like that, okay, and you know that some human behavior is being tagged together. The conditions are there, okay, and it is good enough for you to make predictions already, as long as it's not like the lower left corner's graph. Now, just in case some of you go read journals and you find that, oh yeah, they report this. Now, let's look at these numbers. Suppose, right, I report the markers are good. They are medium, but they are tony. Okay. It's not just the stick here, still have to use a lot of strength. Now, I want you to look at the correlationship, right? The symbol for it is usually an R symbol. So suppose I report two correlations. One is positive 0.4. Then another correlation is negative 0.6. So this correlation, right, is always ranging from negative 1 to positive 1. Now, the question to you is, R1 or R2, right? Which one has a stronger correlation? For those of you who have learned statistics before, I think chicken feed. But to the rest of us, R1 or R2? Okay, show of hands. Who thinks R1 has a stronger correlation? Raise your hand. Who thinks R2 is stronger? Raise your hand. The rest sit on the fence because they are equal. Okay, more hands I saw raised for R2, and that is correct. Whenever you read, right, be careful, you should separate the sign from the number. The number ranges from, I said, negative 1 to positive 1, right? But actually, so although, a different color, or clearer, I said it's negative 1 to 0 to positive 1, correct? But actually, the sign, if you remove the sign, right, it is just simply 0 to 1. And the numbers tell you the strength of the correlationship. The sign tells you the relationship, right, is it moving in the same direction or opposite direction? Meaning what? For delinquent family, right, increased number of years of broken family equals increase in delinquency behavior, correct? Same direction. So it will actually be a number from 0 to 1. So if it's like 0.7, you know the trend is very high. On the other hand, if you look at something, let's give something simple. Okay, exercise and weight gain. When you exercise, let's say you are not going to the gym and do what sculpting, all this, right? Just normal running. Okay, so you're not deliberately building muscle mass. But the more you exercise, the more your weight will drop. If you start off as a plump person, correct? So they are now in the opposite direction, isn't it? More exercise time, weight drops. So this will give you a negative sign. So if you eventually found that the relationship is 0.6, then you can conclude that there is a moderate trend between exercise and weight gain. In the sense that increase in exercise will lead to loss of weight gain. Loss, so it drops. Got it? So next time you read any papers, you find that if they report this thing, now you know. Don't mix the two together. The sign is the sign. The sign tells you how the two conditions change. The numbers only tell you, the number is the one that tells you how strongly they correlate. Last part, the numbers are not percentages. So even though it's 0 to 1, one correlation is not 100% it will be. It is just an index. There is another formula to convert this to percentage, but it's beyond your syllabus. Okay? What now? Okay? So sometimes books don't just report the percentages, they simply report the number to give people an idea. Generally, we take it that if it's 0 to 0.2, there is really no big correlation, so no trend. Even though 0.2 is already showing like this is 0, like this part is 0, so 0.2 you feel that it should be becoming more like this, right? Yes. But 0.2 is really no big deal. So anything from 0 to 0.2, the scientific community out there usually thinks that no, we just ignore, no relationship. From 0.2 to 0.5, they will tell you yes, there is usually about 0.2, 0.4, they will say okay, there is a small relationship. And then 0.5 to 0.7, they will tell you there is a moderate relationship. Anything above 0.7, 0.8, then they will tell you there's a strong relationship. And why there's like the numbers are not exact, because all these are based on graphs, so there is no specific like they tell you. But if you go by statistics, they have. Okay, but that's beyond the syllabus, so I won't talk about it. Yeah. Like when we do this, then we convert to something called the Cohen's measurement. That will tell you the strength of the relationship. Then, so that people will actually tell you whether it's mild, moderate, or strong relationship. But generally, if they just put like that, you just roughly know, okay, that's the number, you get the feel, that's good enough. Okay? Alright, I have nothing further to add. The remaining thing is to share with you that, of course, there are ethics controlling the research and the discovery of new knowledge. In the past, people can I think I shared with you a study on the poor child, where phobia was it this last week? No, okay. So in the past, people can do a lot of things. They can even force an 18-month-old infant to suffer from phobia just to observe. Okay? But that was a time in the 1920s and 30s when there was no ethics board. Today, you can't do this kind of experiments. So today, there's a lot of regulation over how we produce new knowledge or discover new knowledge. It's also within psychology. And it's not just for humans, it's also for animals. Alright? So animals are also protected. For example, if you have to do experiments on animals, the animals, other than experimental time, the animals get 5-star hotel treatment. So they have very big cages where they are supposed to have enough space to run around, to interact with their own. If they are in mixed groups, they have enough food. Food are all measured to be nutritional for them, everything. Okay, only not nice part is the experiment. There are authorities to audit this. In developing nations, you wonder lah. Alright? Even for human studies also, there are a lot of loopholes. That's why 2 years ago there was this China gentleman, right, who was a human genome technologist, right? So he go and meddle and go and create 3 babies. It's not 2, it's actually 3 babies with improved genes that will not be that, so that these children, when they grow up, right, they will never succumb to this human immunodeficiency virus, which is AIDS. But then these are DNA altered humans. We have no idea what they will grow up to become. Alright? That's from China. So, but in all the developed nations, then you find that there are many boards, committees set up to actually cross-check and make sure that auditing is done at a standard where I suppose there will not be 100%, but it's a minimal of ethical breach. Okay? So this kind of things also applies to psychology. Only thing is, culture may sometimes change a bit of the rules. Right? But relatively, all animals, insects, and humans' behavior under study, all these participants, their welfare must be fully taken care of. So all in all, you find that this was the trend we talked about too in psychology, how it changes. So from last week we talked until now it's the end, right? We talk about the various disciplines and how they are, whether the arrow show you whether they are in declining popularity, or they are maintaining status quo, or they are in increasing popularity. Okay? All right, for the next part, it's on bioscience. But I think the thing that you find heavy might be the technical terms. Otherwise, we will not actually touch on the very nitty-gritty details. We are going to look at broad structures of the brain this week. Then next week, we will deal with now. That means now. Okay? Next week, we will look at some of the applications. Plus, some parts are also moved to other lessons. Like if you look at your last lesson, it's on sleep. Yeah. But sleep, the chemical changes and your behavior are all tied in together. So for example, some people might ask me how to get better night's sleep. Should I be facing light, no light? Should I be wary of blue light from the computer sources? These kind of things. Because these things can affect your chemicals, your nervous system. That is to field of neuropsychology. So I will move some of these until like the last lesson, the last topic now. Okay? Question? So today we'll just breeze past this thing. The important parts I will stay longer. Otherwise, you know that you're probably not going to be examined anyway. Alright, the first thing is of course always to answer, where do we get the information? Well, these are some of the things that we do. Lesioning means you spoil one part of the brain, then you compare to a healthy brain and you look at the differences in behavior. So now you know which part of the brain does what, right? We cannot do this on humans deliberately. But there are animal studies doing that. So in the past it was more barbaric. Nowadays, the lesion is more painless because what they will do is they will inject the substance. There is no pain receptors in the brain. So if the animal is put unconscious first, and then the substance is injected to knock out parts of the brain, the animal won't really feel it. But the animal will probably be frustrated because it cannot, for example, maybe if it's knock out motor ability, so it can't balance properly. Okay? We also have nowadays newer techniques, but I'll come to that later on. So lesioning is really damaging a part of the brain. In the past, they can't do this on humans, so they could only get people who survive brain injuries. Maybe they survive road traffic accident. And by the time we reach the 70s, they can scan the brain and know that which part is spoiled, so instead of cutting it open. But if you look at basically almost 100 years ago, usually the survivors, right, they won't kill the person. They will observe the person for maybe say 10 years. Eventually the person will die. So when they die, right, they would have already secured permission to have the body donated for scientific studies. Then they will cut open and look at which part of the brain was damaged. Alright, animals don't get that kind of treatment, unfortunately. But but humans have always been very barbaric, huh? But we are improving, we have newer methods. So lesioning is what? Lesioning is simply spoiling the brain and compare with a healthy brain. Then there are other ways. I will leave you a brief video to watch. Have you updated your email? I asked you all to update, right? Okay, so you'll be able to, don't watch from the Dropbox itself. Please download and watch. Because if you watch, you will take up the resources, you will jam other people who are trying to download. Alright? So this EEG, electroencephalograph, is really measuring your brain wave. In a nutshell, what it does is actually your brain and your spinal cord, your nervous system, they function on electricity. all the nerve cells, they fire very tiny electrical impulses to one another in order to communicate. It's just that you don't have a battery pack in you. Okay, but you are electrical in nature. So this thing measures the overall electrical activity, like which parts of the brain is having more electrical activity, which parts having less. That's EEG.
So like when you're doing something, which part lights up?
Yeah. But the lighting up is now into other things too. So whilst we measure, also for this EEG, it measures the electric current in the brain directly. There are other ways where we can look at the brain without opening up the person. So CT used to be known as TAT, but it was because last time the machine can only keep the person in one orientation. But then recently, ever since the 2000, the CAT scan becomes very advanced. You can rotate the machine all around. So they renamed it, call it CT scan. Basically, what this is that it is a very refined shots. Okay, so multiple shots of X-rays at different intensities to the brain or other parts of the body if necessary. So these X-rays are then analyzed by a computer. So the computer will piece together a picture that correlates and see what is the damage or whether something at the part is going on fine. So CT is good to look at the structure, the components, the parts, where are they? Or if there's stroke, for example, so there's bleeding, so the part is destroyed, CT can also tell. But problem with CT is, it is still picture. You don't know what are the changes to the brain. So if the brain is thinking, you will not know. So then we need other things. For example, we have MRI scans and PET scans. So their names are written here. So all this, right? So for PET scans, what happens is there's a radioactive substance. It's not enough to kill you or injure you. But you take it and you will be absorbed in your blood. So when it reaches the brain, so for example, let's say they're scanning the brain, right? So when it reaches the brain, as the brain uses up the glucose and everything around, it will also pull some of the radioactive substance, alright, to get along with it. So the radioactive substance, whereas it's moving in your brain, it sends out a signal which is detected by the sensors around, and the computer then calculates and works out a picture of what is happening inside the brain. So if there are any changes, it will be reflected. MRI, it works on the same thing, except that it doesn't use radioactive substances so much. Instead, it uses a very strong magnetic impulse to influence the water molecules in that your blood is 95% water. So it influences the water molecules to rotate in a certain direction. When molecules are anyhow rotating, the magnetic field is just neutral. But when you have plastic and then for the fraction of a second, they align, they will then send out a strong magnetic signal, which is detected, and then after that it's calculated, and so they piece out the picture of what's happening in your brain. In other words, MRI doesn't really scan your brain. It scans the blood flow in your brain. So those parts of your brain that is using a lot of resources, therefore requiring more blood, when they use it, the changes will be shown. Okay? So that's what we have. We have CT to look at structure, still images. We have positron, PET scan. All together we have about 10 kinds of ways to look at the brain. The common ones are just listed here. As for then you say, but I already got PET scan, why do we need it?
MRI can symbol really good.
No, not true. It depends on what you want to see. There are MRI scans can capture, but only for a brief period, because of the way the water molecules work, right? So if your exposure is, if you are looking at changes in the brain that will last for a long duration, like 2 minutes, an MRI scan is actually quite useless. It will not be able to track such a long change. But it has, but what Edwin said is correct, it's clearer in the sense that certain resolution is better. Especially those very fluid spaces. On the other hand, there are also more solid stuff inside the brain. Then, in this case, you need PET scans. And PET scans can be retained for longer because the radioactive isotope, right, you can adjust it so it won't decay that quickly. So if you need to look at maybe say how a person thinks over 10 minutes, you throw a person tough questions and you want to see how the brain functions for 10 minutes, you have to use PET scan. MRI scan wouldn't be able to track that long. The things would have changed and it would be unclear. So we always weigh between what we want to see. Is it a very fluid filled space? Not so. And we also look at, is it going to take a long time or a short period of time? Will the changes be microseconds? If it's a split change, we use MRI. If the change is going to be slowly across time, we use PET scans. So different instruments for different users. I think that should be good enough. I think roughly you now have an idea of all the various tools we have. So let's move on. So in other words, I've cut through all these slides. Okay, the details, you can read about them for recap. Then here is a slide. I'm not going to play this. All right, I will put it up on Dropbox. You can watch it. It's a summary of all the various investigative instruments. So it will be good like summary as well as revision. All right. So these are all done. Now, one of the things that is getting very popular, but not here because it's out of the syllabus, but I think it's good to share. It's called a transcranial. I got tip of tongue. The last name is it's magnetography, I think. So anyway, this is a handheld device. What it does is it discharges a very strong magnetic field. But if you recall, in secondary school, right, we learned that magnetic field and electricity, they can convert. So your inside are all electrical impulses, correct? But when it's electrical impulses, it will also generate a magnetic field. So if you jam this magnetic field, you will then influence the electrical impulse and you will shut the electrical impulse down. So this transcranial something, okay, if you come back to it, when you move through, so for applied side, right, applied purposes, if you run through parts of it, so if you take the thing and you run, it's something like this. Then you take the instrument and you run through this part, you don't have to touch the person, just run through closely. So it will just jam here and then suddenly this part of the brain won't function. So the person is almost like having a stroke, but it's temporary. So how we know we have the person raise their hand, for example, so later you learn that the left hand is controlled by this right side of the brain. So if you run the thing through it, they'll go like that. So you know this part has shut down. Okay? Initially, it wasn't really much of good use because the shutdown area was too wide. But now we are very good at specifically shutting down very tiny locations in the brain. But it's still limited to very surface areas. Can't go deep yet. Alright, so this is useful for investigating. You shut down one part, and what happens? Then you look at the person's behavior. Alright, so after about usually about 30 minutes to about 2 hours, depending on the dosage, and then the person will regain their abilities. So no problem. Alright. So with all this, we are now able to talk about what have we found out so far. Generally, your nervous system is divided into two parts. The brain and the spinal cord forms the central nervous system. And the rest of your body with nerves connected, they are there. It's just that they are mostly invisible. Alright, nerves are actually colorless, can't really see, but they are there. Except when they are like thick branches, like when it first comes out of the brain and then it moves here. So if you slice open the chip here, you should see a yellowish strip there. It is not a blood vessel. It's actually your thick nerve, but wrapped around by all the fatty tissue. So it's visible in that way. Now by itself, you can't really see it. So the rest of the body with nerves, they are called the peripheral nervous system. Okay? Why? Let me ask you a question. All of you can think, right? meaning you can process information. Okay, so I'm talking about thinking in terms of processing information. Now, which organ do you think is processing information for you? That means which organ do you use to think? How can Mr. Lam ask such a simple question? Well, you know, yeah?
I think it's the nerve.
But which nerve? Right? We just mentioned that there's central nervous system and peripheral nervous system, right? So which organ is used to help you think? In other words, which organ is actually used to help you process information?
Brain.
Most people will say it's the brain, right? It's not. It's not just the brain, actually. Yeah, the spinal cord and the brain processes information. So you actually think with your brain and your spinal cord in terms of processing information. So that becomes the central nervous system. The rest of your body, when you can sense things, they are called peripheral because they only relay the signal. They are not involved in information. They are very, very, not totally, but they are very, very uninvolved in information. At this level, just know that the CNS, central nervous system, it helps you think, and the PNS, it relays information.
You said relays information.
So if I tap myself, why would I feel the numbness? Why would I feel the pain? Because all these parts have nerves. These are part of the peripheral nervous system. So it will just relay the impact, and when it reaches the spinal cord and reaches the brain, it will be processed. So whilst you feel it here, like if I feel the tap here, but actually what's happening is the tap is actually felt inside your brain. But your brain will tell you that it came from here. Alright?
Is this linked to why I cannot tell one pencil from two pencils?
Partly. Alright, there's nothing wrong with you, okay? Now, your brain usually processes information that is, it can be emergency or it can be non-emergency. So the brain will process basically all the information. Your spinal cord processes information meant for survival. Like if you need to react in a very reflexive way, suddenly you need to jump out of the way because or maybe I was standing at the back of this and this thing was collapsing, so I need to jump out of the way, right? Now that kind of reflexive movement is probably because of the spine. I think another example is when you touch something hot. Some of you might have done that before. You touch, maybe you're cooking something, you accidentally touch the hot pot. Imagine your brain has to do it. Your brain will, wow, what's that sensation? Oh, I also smell something burning. Oh, I think there's pain now. Now, it may sound funny, but it will probably take about 2 seconds. Then by the time you realize it, oh shucks, I got to chop off my hand. Because it's useless. But why you move it in a split second? Because the spinal cord already finished all the processing. So it says, ouch, move. Then the move signal goes back, your muscle contract, you pull out. Okay? Yeah. So the spinal cord does all the very fast reflexive processing most of the time. Actually, yeah, I use most of them because we still have to give room for the brain to come in. But the brain will do that much later. If you look at much later, it's not really that much. So by about 0.2 to 0.4 seconds, the spinal cord would have finished, and by 0.4 to 0.6 seconds, you would be pulling away. Your brain would only complete the thing in about 0.6 to 0.8 seconds, and if you still need to wait for the signal, it will be somewhere very close to 1 to 1.2 seconds. By the time, lots of serious damage. Okay? Alright? So although I say like, well, it's like way down the brain will finish, but it's really all done in split second. Okay? So this is just a picture showing you how we talk about the different, how we divide the brain up. I don't need you to memorize this, so it's just for your information. So in case you read, you find out, oh, what is all this, what dorsal, ventral, they are simply telling you the direction of the angle of where you look at the brain. Like dorsal means it's from top down, alright, ventral's up, okay? Then you ask, why such stupid terms? Why cannot be front, back, left, right? Because if we use that common term, my right, for example, may not be your right. Right? So, sorry, I can't remember your name. Your name. So if I look over right and say, let's raise our right hand. Different hands. So, but this is easy because we all know our hands. But if I say the right side of somewhere between the shoulder and the elbow, there's something, who's right? Okay? So in order that we avoid all these things, that the technical terms are set up, all right, based on a certain orientation. You don't have to memorize. Like I say, if you go read, sometimes you will see that they go by something called the anatomical orientation, which is usually based on the standard of a human person drawn this way, and then they will tell you the terms mean where, what angle. All right, but no need to memorize. This is just for your info so that you don't become overwhelmed by it. All right, now this part also I don't need you to memorize. I just let you know that your brain is not an organ that is attached anywhere to the inside of your skull. The brain is so delicate, you touch it only, you will probably kill off a few million cells. So the brain is actually buffered by fluid. Okay, inside your head, it is actually floating in a very dense fluid. So this fluid is not like water, it's much denser. Okay, and although your brain, right, is about somewhere around 1.3 kg in weight. Okay, but immersed in this fluid, like you can float in water when you go and swim in the sea. So this fluid is so dense, when the brain floats inside it, you measure its weight, right, it becomes about 30 over grams. Okay, so it's much lighter, but the mass is still there. All right. Now, so this fluid is the one shown in blue. It not only goes, so of course it was produced from the inside, then it flows through the internal drainage, then eventually it will reach the outside, then you will buffer the brain. And this is not forever like that. It is constantly recycled. Okay, the fluid will flow, then you will go back into your veins, and then some other bloods there's new blood comes in, and then you'll be processed, and then the blood cells are split so that the plasma from the split part, the plasma becomes all this cerebrospinal fluid. Okay? Alright. Then I think we just jump to these few parts. Human brain has actually 3 levels. The earlier part of it, which is here, it deals with a lot of your vital functions and movement. This evolved first. Then somewhere when this part, right, is not the emotional brain. Okay, don't get it wrong. This part deals with a lot of reflexive actions. So it probably will evolve together with this, but it formed first. Together with this is the final part of the brain, which is this orange portion. Okay? This is the part where you deal with a lot of what you are capable of thinking. We call it the executive functions. Alright? So when you look at the human brain, you can clearly see 3 stages of evolution. Alright, forming the hindbrain, the midbrain, and the forebrain. For some of the reptiles, you find that their hindbrain, because they never gone through sufficient evolutionary time, they have been around, but they didn't have the kind of deviations like humans along the way, so they never had a chance to develop a big forebrain. In fact, a lot of warm-blooded animals, they don't have the kind of brains that we have. Alright, I will say what later. Now, so let's look at the hindbrain. I need you to read this on your own and remember what the terms. I will let you know roughly what's their function. Actually, I need not. I just elaborate them. They are all underlined there. Now, so as you can see, this portion here, so where's the medulla oblongata, right? There. The word medulla is shown. There are several medullas in the human body. So medulla oblongata specifically refers to that purple color, the lowest part of the purple color thing.
Does that mean it's like here?
No, it's probably because you're actually pointing it way below. So you will, I suppose if you point a bit slanted like that up here, yeah. Okay. Now, and then you can see the pons. Okay, so maybe what I can do is, I'll tell you what, you take a quick skim through this. I will use the picture so it's clearer. So know that you have three parts. You're going to look at medulla, pons, and cerebellum. Alright, it seems like there are certain important behavioral functions, like even vital functions, such as heart rate, are involved. Right, skim? Okay, using this picture, right? Or maybe they can, I don't know whether the online people can see it this way, but so I've turned the camera to look at the chart. Are you good to go, right? Online people, can you all actually see the arrow moving across the screen?
Yep.
Okay, then forget it. Let me not. But it's still too small. Okay, so a few things to take note of is one. Now, this medulla, it houses the processing parts for your breathing and your heart rate. What does that mean? You notice that you can just leave your breathing be, and you will just unconsciously breathe in out. So this is regulated, alright? The nerves that control this breathing is actually housed inside the medulla. So with this intact, you stay alive. But you can override this. Alright? Humans is the only animal that can override this. That's why we can regulate our breathing to do meditation. Animals can only pant when they are worked up. We can hold our breath, we can do a lot more. The reason is because although this part is reflexive, that we have evolved something over at near the top to send signals down to further regulate this. So we are not totally slave to the reflexive breathing. And then, so we are capable of more actions like mindfulness exercises, like meditation, these kind of things. Okay? So if you want to talk about enduring pain, alright, animals have their own mechanism, but it's never through mindfulness, meditative kind of exercises. Alright? They are very hormonal driven, but we can override some of these. Now, if you move up, here, this is like a bridge. This is the part where it sends signals towards the brain and towards the spinal cord and send to and fro from the cerebellum. So the pons is literally like a communication center. Cerebellum, this one is important. You just know three important functions. One, it regulates your balance. So it regulates meaning you can still balance if your cerebellum is spoiled, but you can't balance properly. Okay? Animals with this part damage, we look at their behavior. Like for example, birds, right? Birds cannot fly with their cerebellum damage because they cannot stay balanced enough to hop off. For birds to flap, they can flap their wings, but they need to push off the ground to flap. But they can't, they wobble, cannot push off, so can't fly anymore. For humans, if this part is damaged, so you will lose balance, because your balance, you can struggle to walk, but you cannot run, you cannot do fast. Okay? Next, this part also houses a lot of your motor memory. What's that? If you have learned how to play badminton, not because of the rules, but because you know how to swing the racket, that's because the memory is housed inside there.
Or more bitter than muscle memory.
So yes, so once you lay people call it muscle memory, but muscle really has no memory. Okay. So the cerebellum holds all this information. If it's damaged, not only will you also, you will usually just be like, oh, you lose balance, but actually it could be because you've lost that information. You can't play badminton anymore. Furthermore, you are unlikely to be able to learn a new motor skill. So let's say you have never learned to type. Okay, you just learn to communicate normally, and then suddenly you're involved in a road traffic accident, cerebellum damage. So now you want to learn how to, you can't speak, but you want to type to talk to communicate with others. But you find that no matter how you practice, you just won't be able to master the typing. Okay? Of course, it depends on the extent of the damage, but there is a very high risk that once the cerebellum is knocked out, some parts, you will not be able to learn new skills. Skills that require motor behavior. Alright? Oops. Okay, we'll end in 5 minutes. Yeah.
The cerebellum or any parts of the brain, is it if you go through, if something happens to you, then you'll be damaged, or as you grow and you age, you will decrease in functionality?
Once you age, you are damaged only because there are a lot of tiny capillaries that will still burst in you. So, barring a big stroke, there will always be micro strokes. So, somewhere around 30, 40 years old, most humans will start to have micro strokes. It's not enough to render you, like slurring all this. And it's also not significant, so you don't really notice anything until about 70, 75 years old. Then you find that somehow you really cannot keep up. But a lot of humans tell themselves, what? When you ask let's say not even 70, let's ask a 59 years old, that's 1 year to old age. Alright? You ask the person, do you think you learn language fast, or your, let's say 17-year-old kid, learns a new language faster? Who do you think learns faster? Now what do you think will be the response?
They will say the younger one.
And then they will tell you, of course I'm so old already, right?
Yeah.
Sibo. So a lot of people cannot learn because they tell themselves, oh, I'm too old already. Okay, they already activated the brain not to learn. This kind of micro strokes, whatever, won't affect, major strokes, yes, but micro strokes won't really affect you until about 70, 75 years old. And this is based on 15 years ago data. Today, it's going to be different because for the last 10 years, you find that human health and human medical technology has leaps and bounds of improvement. Okay? So, it is likely that the age won't be pushed like 100 years now. Maybe 75, 80 years old, then it will seriously start to affect you. Especially for people who watch their diet and do sufficient exercises, that's a different story. Okay? Well, that's another story. Yeah? So we have balance, we have learning new skills, alright, and we have learning is one thing, but remembering all the movement, everything, it's all there. So there's memory, learning, and balance. You knock out cerebellum, that's it. You can you won't have quality of living anymore.
Is speech under this?
Yes and no. Only control of the movement a little bit, like how to move a bit of the vocals, but not that much. Speech is really elsewhere in the brain.
That is only dying.
Okay. Okay, now, I think, let me just sum up the rest. This midbrain part, like I said, deals with reflexive thing. So if I go, suddenly you become awake and you look at me, right? But why don't you look elsewhere? There is one part that makes you react very fast. Measure the sound, the loudness, the everything, all calculated in split second, and you will attend to that location. It's all in your midbrain.
Is that its only function?
The simple answer is yes.
Oh yeah.
Okay? But the answer is really no. all your visual reflexes, your auditory reflexes, anything that is reflexes, kind of speed, this is the part. Then you say, but I thought the spinal cord. Well, the spinal cord does, but it does a lot of tactile one. Over here, if you have to turn to the correct direction, you have to, those people, they competition shooting shit, and then they will, it's all, a lot of the control comes from here. So if you look at people comparing us and them, this part is very active. Okay? Yeah. Then, before we go, this thing, we will talk about it in details next week. I'd like you to read up, like, this slide, don't have to pay much attention to it. For those who are interested in how it changes, I will also put a video there. Alright, so video 1, video 2, you can watch it on your own. You can read this, starting from here, right? See all these slides, forebrain. Read it before you come. I will just summarize it all. Okay, I will focus on this thing. Your forebrain, what it does. At least the 4 main parts. So next week when we come, this is the part that we will basically jump into. The rest we will still move very fast. So in case you are concerned, just read ahead of time. Okay? All the way until this slide. This is going to be tested. For this one, how much of it? Very much of it. The one that you skim through, like all these neural tube, the vital functions, midbrain. Okay, let's go. I'll give you the complete information. There are certain things I want. Alright? Okay then, I'll see you all next week.
Mr. Lam, hi.
Yes.
Right here.
Yes, right.
Yeah, I haven't got the lesson recording from last week. I haven't got the lesson recording from last week.
Hello, Suda.
Yeah, hi.
Next week by tomorrow.
Oh, okay, yeah. So I would like the last week lesson recording and this week too. Because I want to go through the lesson again. I've went through the notes, but because the notes and the lesson that Mr. Lam gave got